we have studied the matrix representations for operations. Collection of operations, nothing but the group or point group. Whatever the matrices we derived for the different operations, if we collect all matrices, then that will be the representation for whom? Point group. And that we are going to study. What that exactly representation mean? Can we reduce that representation? How to do that? Those things to be what studied. For that, basic necessary is the matrices study. In 3 coordinate system, we derived the matrices. Now those matrices we can derive in 3n coordinates. Means n is a number of atoms. If I consider, say, water as a molecule, 3 atoms are there: oxygen, hydrogen, hydrogen. For each atom 3 coordinates we can consider. So total number of coordinates 9. So 9 dimensional, 9 by 9 matrix we can what prepare for all operations. Similarly, if I consider ammonia molecule, then how many atoms are there? 4 atoms. For each atom 3 coordinates. 3 into 4. 12 coordinate system we can establish. Similarly, if I consider methane molecule, then for that how many atoms are there? 15 coordinate system we can establish. 15 by 15 matrices may what possible. We are not going to discuss those large matrices in detail, but at least for C2V point group, we will obtain those matrices. Means what exactly happening in the C2V point group? For example, say water that I discuss with you. Let me consider this is hydrogen 1 and it is hydrogen 2 and here is oxygen. While establishing matrices, you should know the coordinate aspect. See, x, y, z coordinate. This is the first atom I am considering. x1, y1, z1, 3 coordinates are there. What is the direction of the coordinates? That is a positive y direction towards you, positive x direction towards your right side, and positive z, that is towards upside. As like 3 coordinates are there for this atom, that's a hydrogen atom. Like a second atom in the molecule, that's oxygen. 3 coordinates will be there. Here x1, y1, z1. x2, y2, z2. Similarly, third atom in the molecule, that's the second hydrogen. So 3 coordinate system will be there. x3, y3, z3. What happens for those 3 coordinate system? That we have to find out. If I perform identity, then there will be no change, so you will understand. But if I perform C2 operation, then whatever the x coordinate is there, means which is towards your right side, after rotation, when I rotate that x coordinate will be pointing to the your left side. So x1 will become minus x3. Similarly, the y coordinate, if I talk, is origin position. Y coordinate positive is towards you. It's a y1 coordinate. After rotation of 180 degree, that y coordinate will point towards me. And here it was a third atom, no? So y3 was there. So y1 will convert to minus y3. And what about z1? Z1 was positive. After rotation also it will remain positive. So Z1 simply will convert to Z3 because atom position is changed. What about oxygen? That we already discussed. After rotation of 180 degree, X2 will become minus X2. Y2, second atom therefore. Y2 will become minus Y2 and Z2 will remain as it is. Only for hydrogens position is changed. So x1 is converted not minus x1, minus x3. Y1 is going to convert to not minus y1, minus y3. And z1 is converting simply to z3. So such convergence you have to imagine. For that proper operation you have to perform. Now shortly I inform you about the molecular plane. When I perform the operation through the molecular plane, then plane is xz plane. So who is not there? Y is not there. So y coordinate will change. Whose? For this atom. Atom position is not going to change. So x1 will remain x1. Y1 will become minus y1. Z1 will remain z1. Y2 will become minus y2. Y3 will become minus y3. Other things will remain same. If I consider sigma yz plane, a plane perpendicular to the molecule, in yz, who is not there? X is not there. So x coordinate will be what? Negative. For central oxygen, okay, it is not changing place. If it is not changing place, then you can just say x2 becomes minus x2. But these hydrogens will change. Atom number 1 will come to the position of atom number 3 in the molecule. And atom 3 will come to the position of atom number 1. So what will happen for that x1? x1 will become minus x3. And what about x3? x3 will become minus x1. So in detail, The discussion is given there and the establishment of 9 by 9 square matrix is done. But those matrices become so huge, representation becomes tedious. Then one way out is there. We can find character for the matrix. What is character? Summation of diagonal elements of the matrix. And that character is enough for us to describe the chemical aspects. Therefore, I was emphasizing while establishing matrices, remember the character, understand the point, character. Character of identity we say as dimension. So we can get the summation of those diagonal elements and we can get representation. Various representations are possible. Representation always remains with dimension. What is dimension? Character of identity. We can reduce it with other representations which are with smaller dimension. Then original representation can be considered as reducible representation. And whatever the new representations are obtained, if we could not reduce them further, then those will be irreducible representation. So how to obtain reducible representation, how to obtain irreducible representation, that we are going to study. But in this video, you are going to learn what exactly reducible and irreducible representation mean. Various examples that I am going to discuss. For each atom in water, I am considering 3 coordinates. Say for one hydrogen, x1, y1, z1 as a coordinates. Say left side hydrogen. Central oxygen, coordinates x2, y2, z2. And right side hydrogen, coordinates x3, y3, z3. On those coordinates, if I perform the identity operation, means on water molecule, what do you think? Will there be any change in the coordinates? Absolutely not. So how can I represent that result? See, 9 by 9 matrix is represented. Along diagonal, 1, 1, 1, 1 is there 9 times. And then x1, y1, z1, x2, y2, z2, x3, y3, z3, such coordinates are there. So what is that middle representation? It is a matrix of 9 by 9 order. And what we say? Character of identity as dimension. What is character? Summation of diagonal elements. Which are diagonal elements? 1, 1, 1. How many times? 9. So 9 is a dimension for this matrix because it is an identity matrix. During representation, we are not expected to consider only one operation matrix. We have to consider other operation matrices also. Identity will represent dimension because every matrix will be of the same order. And the character for identity we consider as dimension for that representation. I am coming to that point. Let us see now the other operation. Say C2 operation. How can we obtain the matrix for it in 9 dimension? What was our matrix for C2 when we consider XYZ coordinate? -1, 0, 0, 0, -1, 0, 0, 0, 1. Such 3-dimensional matrices I have to replicate 3 times. But where to represent them? Where to arrange them? How to represent them? That should be what very clear. Here I said matrix of 3n dimension. What is n? Capital N there. Number of atoms. Here in water molecule, 3 atoms are there. Therefore, we are talking about 9-dimensional representation. Just imagine, if we rotate the water molecule by 180 degrees, then hydrogen 1 will come to the position of hydrogen 3. But imagine the rotation. The coordinates x1, y1, z1 on hydrogen 1, how will they change? One by one, let me discuss. x1 of hydrogen number 1 will become minus x3. So as a coefficient for x3, -1 is there in the first row. y1 of atom number 1 will become minus y3. So for the coefficient of y3 in the second row, -1 is represented. And Z1 of atom number 1 will become Z3. It remains positive only. So for coefficient of Z3, 1 is represented. I hope you are getting this point. Accordingly, for central atom, that is the oxygen atom, what will be the coordinates? The x2 of that atom will become -x2. y2 will become -y2. z2 will become z2 only. Therefore, -1, 0, 0, 0, -1, 0, 0, 0, 1 is a representation at center. As the case happened for atom number 1, that's hydrogen 1, same case will happen for hydrogen atom number 2, that is total atom, third atom. So what will happen here? x3 will get converted to -x1. y3 will get converted to minus y1 and z3 will remain as z1. So this is a representation for which matrix, which operation? Yes, C2 operation. It is a 9 by 9 ordered matrix representation. What is the character of this matrix? Summation of diagonal elements minus 1 plus minus 1 plus 1. Answer is minus 1. Yes, for this 3n dimensional, this 9 dimensional representation, C2 matrix has character minus 1. Let us see now the third operation. It's a molecular plane, sigma xz. What do you think? Atom number 1 will remain to its position or will change the position? Will remain, but few coordinates will change. Same thing will happen for atom number 2, that's oxygen, and atom number 3, that's our second hydrogen. How will be the coordinates? Because we have studied in xz plane, y coordinate is not there, so there only minus 1 will come, otherwise 1 will remain. Means 1 0 0 0 minus 1 0 0 0 1 is a representation for sigma xz matrix. But here we are representing it in 3n dimension. N is a total number of atoms. So 9 dimensional representation. What will happen for x1? X1 will remain x1. What will happen for y1? Y1 will become minus y1. For z1, it will remain z1. Similarly, you will understand x2, z2, x3 and z3, there is no change in the coordinates. But for y2 and y3, there is just a change in the sign. Means y2 becomes minus y2 and y3 becomes minus y3. So now see the diagonal element. See the diagonal elements, 9 elements, and do their summation. What will you find? Character for that matrix is 3, which is summation of all diagonal elements. So in 3n coordinates, character for sigma xz will be 3. Just keep in mind. How can I represent the matrix? Yes, it's a 9 by 9 big matrix for molecular plane sigma xz. Similarly, let us have attempt to understand representation for sigma yz. See, sigma yz is a plane perpendicular to the molecule. Because of reflection through that plane, hydrogen number 1 will come to position of hydrogen number 2. Means from our new nomenclature, atom number 1 will come to position of atom number 3. How the coordinates will change? X1 of atom number 1 will become minus x3. Y1 will become y3 and z1 will become z3. So coordinates at the right corner see there in square matrix minus 1 0 0 0 1 0 0 0 1. That's a 3-dimensional representation. And at center, same sequence minus 1 0 0 0 1 0 0 0 1. What does it mean? X2 becomes minus x2, y2 remains as y2, z2 remains at z2. As I discussed for the atom number 1, x1 change in the terms of x3. Now x3 will change in terms of x1. Means x3 will become minus x1, y3 will become y1 and z3 will become z1. So this new matrix is in front of you. What is the character of this matrix sigma yz? Summation of diagonal elements minus 1 plus 1 plus 1. What is the answer? 1. Remember, keep in mind sigma yz character u1 in 9-dimensional situation. In 3n coordinate, we are finding as 1. Yes, from this you might have understood how big or how large the matrices we can obtain. Here only I consider 3 atomic molecule, that's H2O. If we consider large atomic numbered molecule, then for 3n coordinate system, in 3n dimensional system, very big matrices there will be. Then what is the solution to obtain this proper representation? A solution is finding the characters. Therefore, whenever matrices we devise, I was repeatedly asking, find character for the matrix. And that character will be the representer of that matrix. So now in square bracket I was representing, I can represent them without square bracket, only simple summation of the diagonal elements, then that will be the collection of characters. Yes, collection of characters for all symmetry operations possible for that point group will be the representation. Now our new definition for representation, and that representation can be reducible. If we could able to obtain a new representation of lower dimension, then that previous representation is reducible representation, and whatever the new representation we are getting, if we could not reduce it further, then that will be irreducible representation. Now if we consider definition of the representation as collection of representation of all matrices, then that will be a very heavy task. What is the solution for that? Represent characters of those matrices in spite of complete matrices, and collection of those characters as a representative of the matrices or those operations is nothing but our representation for the point group. What is character? Character is a summation of diagonal element. For example, gamma xyz was our previous representation. Whichever the matrices are there, just I do summation for the diagonal elements. Means for identity, summation is 1 plus 1 plus 1, 3. Likewise, for C31, it is 0. C32, it is 0. For sigma xz, it is 1. For sigma dash, it is 1. For sigma double dash, it is 1. So what is that? In sky blue color representation, 3, 0, 0, 1, 1, 1. It is representation of dimension 3. What is dimension? Dimension is a character for identity. What is the character for identity in that sky blue color representation? 3. It is a 3-dimensional representation. If I could reduce it in further parts, then that sky blue color representation will be reducible representation, and those further smaller parts will be with lower dimension. And that already I did. That sigma xy is a new representation which can be obtained from sigma xyz, and that new representation I am representing in terms of characters. Matrices are already there in front of us. In yellow line, in yellow strip, I am representing that gamma xy representation. What are the characters? 2, -1, 0, 0, 0. That is our irreducible representation because we can't reduce it further. Now, last representation, gamma z, in matrices we represented in that square bracket 1, 1, 1 everywhere was there, but that was matrix. Only one element. So it itself is a diagonal. Summation of diagonal element means 1 only. So in yellow strip at bottom, all 1 are gathered together. So those 1 representing characters of those matrices is our representation. So collection of all the characters which I represented in the sky blue color, that is our reducible representation. Collection of the numbers means characters of respective matrices in yellow band, yellow strips are our irreducible representations. In short, representation is a collection of characters of all possible matrices for that point group. In a combined representation is our representation. If we could reduce in lower dimension representation, then that will be reducible. Otherwise, it will be irreducible representation. I hope now the concept of reducible and irreducible representation is clear to you. One important thing I like to inform to you. See the characters of operations which belong to same class. For example, C31 and C32, these two operations belong to same class. Their characters are same. Let you consider reducible representation simply gamma or irreducible representation gamma xy or gamma z. Similarly, 3 vertical planes constitute same class in C3 point group. See their characters. Let you consider reducible representation gamma or irreducible representation gamma xy or gamma z. Characters are same. So in future, I will not represent all the operations, because if I consider tetrahedral point group, then how many operations will be there? 24. So there we will follow a proper technique of representation that point group in terms of classes. Are you following? So next time, whenever you will find the character for particular operation in the class, it means all members present in the class carry the same character. So now onwards, we will talk the representation in terms of characters. In case of C2 point group, as a 3-dimensional representation, we could reduce it in 3 parts: gamma x, gamma y, and gamma z. Regarding gamma x irreducible representation, I am asking question. In that gamma x representation, what is a character of operation sigma xz? That character, whether 0, -1 or 1, that answer you have to write in the comment box. I repeat, for C2V point group, for gamma x representation, that's irreducible representation, what is a character for sigma xz operation, that you have to write in the comment box.